Welcome to Engaging Ideas, where we bring information and ideas from the academy to the community to help think about real-world questions. When we think about colleges of education, it's usually in the context of training educators, and certainly that's a central role both here at the University of Denver and elsewhere. But the best schools of education are, like DU, places that focus not only on the transmission of knowledge, teaching, but they are also places where knowledge is created. Such knowledge informs not only the training of educators, but also provides information that can be of tangible value to parents, grandparents, and others who interact with children. And nowhere is the practical benefit of educational research better illustrated than in the work of our guests today. Joining me from the University of Denver's Morgridge College of Education are Professor Julie Sarama, who holds the Kennedy Endowed Chair in Innovative Learning Technologies here at DU. Her research has been widely published. She's the author or co-author of more than 100 articles, 4 books, and other publications. In addition, Professor Sarama has been a principal or co-principal investigator on 7 projects funded by the National Science Foundation, and she is currently involved in co-directing 3 large-scale studies funded by the U.S. Department of Education. Professor Douglas Clements holds the Kennedy Endowed Chair in Early Childhood Learning. He's published nearly 150 refereed research studies, 26 books, and other publications. Like Professor Sarama, Professor Clements has led numerous large-scale grant-funded research projects. Collaborators on many projects, this remarkable husband and wife research team are nationally known scholars who focus much of their work on how very young children relate to math and what that means. I think you'll find their research and findings to be of great interest. Professor Julie Sarama, Professor Doug Clements, welcome to Engaging Ideas.
Thank you.
Professors, you've spent your years examining young children and math. Understand your research shows children have fundamental math competencies from birth. Perhaps that's a good place to begin. Is that really the case?
That is the case. And thanks for your interest in this topic, in this area. In the first weeks of life, cognitive studies show that kids are sensitive to number. It doesn't mean they understand number like you and I, but it does mean that they have inborn capabilities in differentiating, for instance, 2 sets of 2 from a set of 3. They're also very good at spatial kind of things. People recognize when they start crawling that they learn very quickly how to navigate. But even from the first weeks and months of life, they understand how to find certain objects and look in the right direction. If they're in their high chair, they know where the food is coming from. And those early competencies clearly develop year by year until they form a cognitive foundation for all later math learning.
Wow. Why is early knowledge of mathematics important for a young person?
Yep, it really is important. We've done most of our work with kids from about 3 years of age to about 8 years of age, right? And the interesting thing is, in that period, especially like entry to kindergarten, it's amazing how predictive the kids' knowledge of mathematics when they enter kindergarten is of their later school success. So it predicts later school mathematics success throughout elementary school, even into high school. More amazingly, it actually predicts later reading success as well as early literacy skills do. So it's not just about number and shape, it's also about the kind of thinking that mathematics engages, undoubtedly, that accounts for it being such a high predictor of later school success. Mathematics still is the queen of the sciences, and you need that to know all your STEM subjects. And if you also need it for reading, it means we risk at our peril thinking about kids' early mathematics development and the kind of equity issues that all kids should have access to charging stations in early mathematics.
We all want our children to be successful in school. So just how early should children begin learning math?
Well, that's a really interesting question. As Doug said, they're sensitive to number as infants. So it's never too early to start thinking about how to interact with children around math. I'm not saying that we want to sit down and teach them formal lessons. That's not anything that we're talking about right here. But we want to build on that sensitivity to number and keep pointing out number consistently. So look over there, those are two trees. Oh, here come the 3 doggies. Things like that. Informal mathematics experiences are so beneficial for kids. We're going to count up the stairs, we're going to count down the stairs. And it's also important to understand what the development is, so that if you're going to count those 5 stairs down to the next level, and then you're going to do that for the next 4 years until they go to kindergarten, you're really not following a developmental perspective and trying to build on what the children know. So it's important to sort of understand that as infants and toddlers, even as infants and toddlers, they should be developing like in everything else.
Well, so what are some ways that parents or caregivers can help children not only learn about math, but actually enjoy it, to learn to love it?
Well, that's another really good question, because lots of parents and caregivers grew up not liking math. So the first thing to do is to recognize that maybe they haven't had the best experiences, and to try to change their attitude so that they can do a better job of not passing that on to their children. So I hear very often people will say, well, what should I do? I hated math. That's the next sentence. So, and then followed by, and I don't like what they're doing in school now, without realizing that if what happened to you, what you did, what your experiences were, made it be that you feel you're not good at math and that you hate math, then why would you want your children to repeat those experiences? We really do want to be open to different ways. We've done a lot of research, and we want to be open to different ways of teaching kids about math, and have the parents and caregivers be open to that, and to approach it in a very fun way.
Well, your work is fascinating. It's received widespread recognition. What kinds of things might our viewers be thinking about and discussing in light of your work in a sort of a practical sense?
Well, first and foremost, that there is no play versus academics kind of dichotomy. Very often what I hear, again, from people who, when they find out what I do,
especially for our work in preschool and kindergarten.
Right. Kids aren't allowed to be children, that we push things down on them. They should be allowed to play. And the first thing that we've learned from our work is that children approach math in a very playful way, and we teach teachers, caregivers to approach it in a playful way as well. Children enjoy it, and the big thing is then the teachers are surprised at what children can do at such a young age and still be happy. It's not that we're drilling them on multiplication facts when they're 4, but we are in fact asking them really extended questions about how they know what they're doing, and letting children respond and explain their strategies in a way that I don't think most people thought was possible.
Yeah, and so it's interesting too, there's other research that shows, beyond ours, that shows that in this play versus academics dichotomy, it is just a false dichotomy, because what a large body of research shows is that if kids do mathematics in an intentional way, they get intentional experiences in preschool, this was, they then later come to free play loaded with ideas, and that free play is cognitively and emotionally richer than if they don't learn the mathematics. And when that free play is cognitively and emotionally richer, kids develop more executive function, the kind of ability to control one's own thinking and emotions and the like, and that helps their learning. So this is like it's just mutually beneficial instead of being at odds with each other, and we try to communicate that to everyone we can.
And another big thing is something just to build on is what I said earlier in terms of taking a developmental perspective. I think that's very important because for years, we grew up that math was like a body of knowledge, And that if you were a good math teacher, you made sure that what you were teaching children aligned with what you were testing. And that was the big alignment. And what we've realized through our research, what I believe that we've really tried to share with teachers and principals, is that if you understand how children think about math, then you're going to do a much better job. So instead of saying today we're going to do page 33, and tomorrow we're going to do page 35. Of course, only the odd pages, because the even pages have something else on them. If that's what you're going to do, that without taking into account the child and what the child knows, you're making a big mistake. And in fact, most of the time, you don't have to do an individual lesson for each child, but taking into consideration that there's usually about 3 developmental levels going on in any given classroom, and you want to be careful that you're tailoring your instruction to meet the needs of those children where they are. And if you do it right, they're all going to be successful.
That's remarkable. Well, Julie Sarama and Doug Clements, thank you so much for sharing your really engaging ideas on the importance of early knowledge of mathematics and the ways that your research is being used to advance mathematics education. I hope you'll join us in the future as we bring more engaging ideas from the Academy to the community. I'm Jim Grismer. Thank you for watching.